This is going to be an Excel video where I show how to obtain some of the descriptive statistics from chapter 3 using Excel. So here you see that Excel has been opened. So let me minimize this. So I opened up Excel. I have a blank sheet, and now I'm going to go into my homework problem that I'm seeing for chapter 3. And there's this little box right here. So I'm going to copy this to the clipboard. It's going to open up this little window, and it says, please copy this. So at this point, there are many ways you could copy this. I believe you can right click and hit copy. And on a Mac, I believe you might hit Command C. On a Windows-based laptop, I can hit Control C. And once I'm done, before I hit done here, I'm just going to click back over here on Excel. And I'm going to select A1 just because that's a good place to start here. And I'm going to right click and I have the paste option. I believe you may also have the paste option available to you with Command V. So let me try that. So Command V or Control V. So Command V would be on a Mac, and Control V is what you get on a Windows. Is how to make it work on a Windows. I'm going to actually, this is all selected. I'm going to right click, and I have this menu of options. And if you're on a Mac, you may need to look for how to do that on a Mac. I don't have a Mac in front of me to show you, and I don't know Macs that well, so I apologize for that, but there's definitely a way to get this exact pop-up. I'm going to hit clear contents. Another way to have done that, if it was not available, is up here on the top. You see all these different tabs, and they are referring to ribbons in Excel. So the home ribbon is sort of like the editing ribbon, and I'm going to come over to the editing area in that home ribbon, and there's an eraser, and there's a little down menu button on the right of the word clear, and I'm going to come down to clear contents. This is a very useful way to clear cells. So I'm just going to clear those contents. Okay, so now we have the data from this problem, and I want to know the mean. If I go back to that problem, it said, we'll say done, let's go back. Okay, it said obtain the mean and median of the data. And the mean is that we were asked to type an integer here. So let's go over here. One way to do it really easily in Excel is just select the cells. And down here at the bottom, Excel tells you the average, which is the mean, the count, so 9 data items, and what they sum to. So you get some descriptive stats that are frequently desired automatically in Excel. So we can see that the average is 8. Another way to do it is just to use the average function. So in Excel, when you want to use a function, you always start with equals. And then if you start typing the word average, you get the average function. And then once I have that average function, I can hit tab, and it pops it in up here on the formula bar for me and down here. Now it's kind of giving me hints on what I need to do. If I click on this, it's just going to describe it. I don't really want to do that. So it's blinking here. I can come right over here to where I have my range of numbers, and I can select all the numbers I want included in that average. And if you notice, the formula was automatically populated for me as I selected those cells, and now there's a dash green line box going around the cells I've selected. And then all I need to do is type in the closing parentheses and hit enter, and I get that mean that way. If you don't remember that the function is called average, Excel tries to help you. There's everything you want to do in Excel, there's at least 3 ways to do it. So one way to do it is go up here to formulas, and you can go to this very first button, which says insert a function. And in here, let me pull this over. I have a couple monitors. You can say find average or find mean. And when you hit that, we're getting average if, which is a more complicated. Why is it doing that? Oh my goodness. Okay, let's see, find average. Okay, it's also not giving me average. Oh, this is silly. All right, forget that. That's giving you more complicated functions than you need. You can go up here to the more functions and go over here to statistical, and you'll see the list of ones. So here's average. So this is going to give you the where you can type in the functions that you want. It's automatically selecting number 1, and I'm going to go ahead and put the range of numbers here, and then just hit OK. So that's another way to get the average. If you knew you used a function recently, you can look at these recently used ones, and it can help you remember which one. And you can get, if you're trying to type in a function, and you can also get to that same search function by this insert function up here on the formula line up here. So just by clicking that, I can also find functions that way. Okay. Now, the next thing that problem asked us to do was to find the median. So we can also get that automatically. You can do it manually, of course. So this is 4, 5, 6, 7, it's just the numbers. Pretty straightforward numbers that we were asked to find the median for. And so for the median, we can number these, right? So we can say that the median position, the position for the median is going to be the number of entries. So what we need for that is the count. So we want to get the count, or little n. So let me I'm going to go to position, and I'm going to cut it. So in order to cut it, I hit either Command X on a Mac or Control X, and I click the cell I want to put it in, and here I can paste it. So this is cut and paste. So I can right click and hit paste, or I could have done Command V for place it here. Let's paste it, as the paste function is Command V or Control V. Okay, so what I really need for the position is the sample size. So I hit tab to go, once I type sample size, I hit tab and it moved me from this cell over to this cell. So here I want to put the sample size, and I need a count. So the way I can do this in Excel, obviously I can look at the number of rows here and say, okay, I had 9. And also I think I told you that down below it gave us a count and the descriptive statistics. But if you needed to get it somehow, the function that does that is count. So as I type, I see all these different counts functions. The first one, it gives me a description. It says count the number of cells in a range that contain numbers, or count A is count the number of cells in a range that are not empty. So that's what you would use if you have a qualitative variable. If you want to do the reverse and just get count blanks, you could do that. And then there's some other functions that are more useful if you have conditional counts, count if and count ifs, and you can learn about those maybe in another video. For now, we just need count, and I'm going to count how many of these we have. So I get that there's 9 values there, and so the position, according to what we talked about in class, so before I type it in Excel, I'm going to put it below. The position, remember, was, and if I want to type something that's not a formula in Excel, but I want to use math, I just start with a single parentheses. So I'm going to say, this is not really intended to be math. This is just text. I'm just writing this to myself as a notation that the position was n+1 divided by 2. Yeah. So let's go over and actually calculate that. So we have to do a formula saying equals. Now our n, or our sample size, is 9 plus 2, plus 2, and we need to put parentheses around that. So I'm going to come up here to the formula bar, and I'm going to put parentheses up here is where you can edit your formulas very easily. So I D4 plus 2, sorry, plus 1 divided by 2. There we go. So we see that the 5th position is the one that we want. All right, so let me go up here to sample size just to keep everybody clear that that's what the little n is in the position. And I can go on the C up at the top. You notice that it's green, and I move my cursor over until that becomes a solid vertical line with two arrows, and that's how I can automatically adjust the width of my cells. Right, so what is that median? Well, the median is the fifth position, so it's the value at the fifth position. So I can just say this is going to equal, and here I can type the position of the cell. Oh, it's telling me I'm in D3. And so if I go to the fifth position, this is going to be 1, 2, 3, 4, 5 is right here. So now the problem asks us to obtain the median. And the way to do that most easily in Excel is to use the median function. So we start typing median, and it's the same thing as mean. We're just going to select the cells that go in here, and Excel is going to do the work for us of determining the median, which we see in this case, the mean and the median are the same. Now you can fast forward past this. I'm going to show you how to find the median according to the way you would do it by hand. And this is just a little bit more of a deep dive into some Excel functions. So if we were going to do this by hand, and if Excel did not have a median function already provided, here is how you would do it. Well, first we need to get the count of how many, so let's kind of work backwards. So the median, according to what we talked about in class, is the value at the middle position, right? And so the middle position, we said, is going to equal the sample size. So that's the, if I want to type something in Excel that looks like a math formula, but I actually want it to show up as text, I'm going to do a single quote. So the middle position, if you remember, is the sample size n plus 1 divided by 2, right? And then I need the value at that middle position. So how do you get all this in Excel? Well, in Excel, the way you obtain these is a few functions that provide this information for us. The first thing is we need the sample size n. To get the sample size n, there's a function called count if it's numeric, or count a if it's something like eye color or qualitative variable. So here's count, and it gives you a description off to the right, or count a, which is counting cells that are not empty. So more useful if you were doing something like hair color or country you were born in or something. But for count, again, we're just going to type tab, and it automatically sort of selects that function for us. I'm going to select the cells here, close the parentheses, just like I did for the mean and median functions. And I see that I have 9 values. Okay, so now that I know the n, right, and let's just come up here. I'm going to click on the cell, and this is how you can edit. Come up here to the formula bar, and I'm just going to put comma n. So we're clear that that's the n that we're looking for in our little formula. So the middle position, and I can just tab, it kind of recognizes this. And now I want to use this n in a formula. So I'm going to say this is going to equal parentheses, right? I'm just copying the formula for the middle position, and I'm going to select the cell where n is instead of typing in 9, so that that could change for me if I wanted to use this formula with new data. So I have that, it's this, whatever the contents are in cell H6, which is the sample size. So H6 is plus 1 divided by 2. And I see that the middle position is the 5th position in this data. All right, so now what cell is that? So that's cell location. And for this cell location, I'm going to say equals cell. No, not cell, sorry, I'm telling you, our address. So address, and the row I want to pick is going to be, and this is just a little bit convoluted, if you will, but if you think about it, the row we need is going to be the fifth row in our data. So how do we find that? Well, the fifth row in our data, or that's what it's telling me, is going to be the first row. So I'm going to pick the first row. So actually, let me pick the row. So I have to type row because I want the row from that cell. Plus, I want to add 5 to it. But really, actually, if you think about it, if I add 5 to the first row, I'm at the 6th position. So I have to subtract 1 off the whatever row that is, because I have it on row 1 right now, but it could have been on a different row. And then I'm going to add to that the middle position. And then the column that I want to identify is I can again select that same cell, A1, because that's the column of the data that I'm looking at. And then I can tab and I can either choose this to be an absolute reference or a relative reference. In my particular situation here, I don't think I'm going to be moving this data around. So I'm just going to say that's going to be an absolute reference, which means if I copy this formula, it's going to continue to give me the right answer. So I am going to click in like this, and we see that Excel is now telling me that the median is at cell A5. And notice the dollar signs. The dollar signs in front of the A and the dollar sign in front of the 5 means if I copy this formula, it's still going to say A5. Whereas a relative reference will change depending on where I copy it to. So if we go to A5, that's here, right? That's cell A5. And it does tell us the median is 8. So so far it's right. So that looks good. But this says A5, and I actually need the median to be an 8. So the median is the value. Oops, I don't want to do that. Sorry, let me come back over here, median. So sometimes Excel wants to fill things in for you and you don't want them there. So let's just say median. And so what is the median? Well, it's the value at that cell location. And in Excel, the way we do this is say indirect. So indirect, and we, yes. I believe, indirect. Okay, I think that's it. Let's try this. Yes. So it's telling me that the cell location, the value at cell A5 is 8. Okay, so there we go. A much more complicated way to get to the same answer. Thank goodness Excel provides this function median. The reason I'm bothering to include this in the video is for those people who would like to continue to learn Excel at a little bit more advanced level. This is the functional way to calculate the median, in a sense, by hand. Okay, so going back to the problem now, we are going to put the mean in here. It's 8. And check answer, I guess. Okay, great. Now it wants the median. We know that's 8. I check that. Okay, good to go. Now we want to replace the 12 in the data set by 102 and compute the mean and median and decide which measure of center works better here and explain your answer. Okay, so where there was a 12, we're going to put a 102. This is what's great about doing this in Excel. We can just come in here and replace this, and automatically we see that the mean has been pulled by that extreme value or outlier. So the value has, if we were to put this on a number line, 102 would be way off to the right, right? And the mean is being pulled towards that tail. Here, the median stays the same. All our calculations stay the same because the median is the middle value. So going back to that problem, in this case, the mean now has shifted to 18. And the median stayed at 8. And that's the whole point of this problem. So now, which is the better measure of center? Well, in this case, we would say the median works better here since it is more typical of most of the data. The mean says this would be the wrong answer. It is not most typical because 18 is a value that's greater than all the data except for the highest extreme value. And you would not say both centers work equally well here because they are not both typical. They're not even close to each other. And you would be wrong in thinking that neither of these is a good measure of center. Actually, 8 is very much in the center of most of the data. Okay, so our correct answer here is that the median works the best. Okay, so that's how we would use Excel to solve this problem. And now we go to part C of this problem, and we see that it says for the data set in part B, this is the one where we added this extreme value, the mean is neither central nor typical for the data. The lack of what property of the mean accounts for this result? So if you remember that what we're saying is that the mean is not resistant to outliers. Since 12 in the data set was replaced by 1 and 2, the mean is pulled in that direction due to that single observation is therefore neither central nor typical for the data. So the word we're looking for is resistant. So I'd say, yes, that's the word. Okay, we are done with this problem now. So now we're at another problem that has some data in it, and we're being asked some of the similar questions. So let's see how we can use Excel to make doing this problem just a little bit easier. So I can go in here and I can copy this to the clipboard. So once again, I get everything kind of highlighted in blue and I need to copy that. And I'm going to come over to Excel and I'm just going to paste it over here in a blank part just to see what I'm getting. So I'm going to paste this here just to see. All right, so I have some information here. And the first thing I'm going to want to do is take this information, I select all the cells. And so the way I did that, let me repeat that, is I clicked on the top left corner and I dragged down to the bottom right corner. So I've selected all the cells in this little block of data. And I can come over here to data and I can sort this data. So I go to the data tab and I have this ribbon. I come over kind of in the middle to the sort and it's going to pop up in this window and it wants me to sort by what. Now in this data, I did not get any kind of header. So I would not click that my data has header. I keep that not checked. And I'm going to sort by instead of column N because that's where the values are. And I'm going to go ahead and sort from smallest to largest. I could go the other way, but I want smallest to largest. So I'm going to say, okay. So now it's sorted everything. So now that I've sorted this data, I'm asked to find the mean. So one way that I can do this is I can copy this data. So I select it. I'm going to hit Control C and I come over to, well, one way that I can obviously do it is just, sorry, let me hit Escape, get out of here, is I can select this column of data and I can see that the average is 31.65. Down here, I see that. Another way that I can check and do this again is Control C and I come back over to where I've already plugged in this formula and I'm going to overwrite this formula. So I click A1, I right click and hit paste. Now notice that I have one extra value, so I need to delete the 9th position. So I'm going to delete that. And notice that now my mean is 31.65 as it should be. If I want to make sure I have the right formula, I can click up here and I can say, oh, okay, well, it did give me the mean, but it's got this blank. I am able to hover over this blue box until I get a little arrow, and then I can shrink my box. I can resize it automatically. Right, now I go to median. I see I didn't actually need to order my values for the median to be found, but I already have. I can click, and again, I can see that my box is bigger than I need it to be. The median function in Excel is able to skip over that blank, but let's say I just want to make my function only taking the median of cells that have numbers in them. I can just shrink my cell that way. So now I see that my median is 28.9. So what happened here? Let's see. Well, my sample size is 8. That seems like it did that right. So let's go ahead and shrink that down. Okay. My middle position is 4.5. Wow. Okay. So now my cell location is no longer right. So again, you can skip over this part if you are not interested in learning a more advanced Excel functions here. The cell location doesn't really exist at 4.5, right? So we need to take the value that's the middle of two cell locations. So this cell location requires that we add below and above values around between 4.5 and 5. So the first thing that we're going to want to do is edit this formula. So the median needs to be halfway between those two values, so that we have 4 values below and 4 in the bottom half of our data and 4 values in the top half of our data. So the middle position now really needs to be modified. It's still at the 4.5, but the cell location. So we need, because this is not a whole number, we need 2 different locations, right? So let's come over here and rename this the bottom. What should we say? We say the max of the bottom half, max of bottom half, the location. And notice that I can't read all of this because I have stuff here. So one way that I can address this is I can click on this cell and I can come back here to this home tab and go to wrap text. And it basically made this height of this cell much bigger. So I can actually make this a little bigger so I can read more of it instead of it being so vertical. Come back here to the formula bar and hit enter. Okay, so the cell location, let's click up here. So it's going to be the row A1 minus 1, but it's adding 4.5. So what we need to do here is add, we want to actually not have the whole cell, we want to round that down, right? So what we can say is the floor. So the floor gives you the integer value. So I'm going to hit floor on this cell. And the significance here is that, let's see that we can click on that so we can, where is it giving me? It's not popping up. Well, the significance here is 0. Okay, so we can hit enter. Oh, it didn't like that. Okay. Let's just go over here and see what floor does. Equals floor. Oh, here it's, I think the one we want is floor math. Okay, so we want floor math of this number. Oops. And we get the 4. So that's the function. So I just explored it over here on the right. So we want the 4th position, and we're gonna, the 2 middle values are between 4.5 is gonna be floor, and then we want the ceiling, so which rounds up. So ceiling math rounds the number up to the nearest integer. So that's the function that we need, and we're gonna apply it to this cell. And we get the 4th and 5th. So over here, where we want the cell locations, let's go back in here and change this. We want the floor. I'm going to actually go up here and edit this whole function. So I'm going to delete that out. And so the address that I want for the max of the bottom half cell location is that address plus 4, right? So I want the, I can now actually select this position here by clicking here. So it's going to give me the 4 there. So that tells me A4, and we can see A4 is where the 4th position is. If you had 1,387 data points, you would definitely want to do this with a formula as opposed to checking yourself this way. You want to make sure it's working. And I'm going to move this down. So I'm selecting it, Control X. I'm just going to move it down out of the way for right now. So that gives me the max of the bottom half cell location, and I need the minimum of the top half, right? Top half of data cell location. And so again, here I'm going to wrap this text. And here I want the location for the top half. And so what I'm going to do here is the same thing I did before. So I can go up here and I'm going to use the same formula. So this equals address, row, from this cell, -1, because I want to start counting one less than it, plus I need to go to the 5th cell location now. Oops, I just realized I need row. I need to close up parentheses and then add this. Okay, and then the column is just that cells from A1. And we are going to go ahead and do an absolute reference here. Okay, so I put that in and I get cell A5. Great. So now I have the contents. I can identify that the 4th and the 5th position in my data is located at cell A4 or cell A5. Okay, now that I figured that out, and notice if I take my data and I copy it down here, let's say, everything stayed the same because all my references automatically updated. They were relative references. Over here in these cells, I was able to identify, in these cells references. So it went automatically and updated that it found the 10th position, it subtracted 1 and started counting. So it gave me the cells that are the 4th and 5th position in my data. All right, so what's the median? The median, remember, is the midway point when you have an even number of data points. Median is equal to midway between 2 middle values. All right, so when you have an even number of data points, you have to find that midway. So let's find the midway between these two. So right now we have indirect is pointing at A13. So if you remember the formula for midway, you're going to add the 2 values. So I'm going to use indirect again. And I hit tab to fill that in, and I'm going to select this cell now. So I'm going to add these 2 together. I'm going to put parentheses around it. I'm going to add some space here. Excel will ignore extra blank spaces. So I'm just doing that so you can see the numerator. And I'm going to divide by 2. Okay, so now I have this value, 28.9. Notice Excel did it much easier using the median formula. But again, I wanted you to understand how to do these type of functions. All right, so back to the problem. So now we know that the mean here is 31.65. Okay, check answer, we're good. Now we want to put the median in. We figured that out. That was 28.9. We're good there. All righty. We want to find the mode. So the mode is R. So what we want to put is the number that happens the most frequently. Okay, so let's go back to Excel. If we want to find the mode, again, we can just use mode. And if you notice, this says returns a vertical array of the most frequently occurring repetitive values in an array of range of data. Or that's multiple. Row single. This is in a array or range of data, a value. So I'm not sure what the difference is between multiple or single, but so the more updated versions of Excel have gotten away from just using mode. I think because somebody must have noticed that if you have more than one variable, I guess you can have more than one mode, I guess I'm not sure what it's doing. I think it's actually trying to find the mode if you have data in both rows and columns. And the mod is a whole different mathematical concept. So let's just go with mode single. So I think that's the simple one. So we're going to come here and select this data. And we get that the mode is 31. Okay. Another way to obtain that information is using what's called a pivot table. And the way we would do that is we would select the data. We'd go to Insert, Pivot Table. And I'm going to say in the existing worksheet, and I'm just going to put it right here, right below, so we can see, actually, let's put it over here to the right of this data. We'll say, okay. And now in this data, oh, it thinks it's called 25. All right, well, let's just go ahead and put that down for rows. So rows, and then we're going to go ahead and for values, we're going to draw this down to values, and we're going to click this down arrow, and we're going to go value field settings, and we're going to go to count. And so we're here, we see that we get the count of each one of the values in our data set, and we can find the location which has the highest value. So the way we would do that is we would say, wow, this actually gets really complicated. You would just say, you'd have to find just the maximum, look through that and find the maximum, and then you can see that it's at 31. So that's the way you would use a pivot table. I think you could actually program, but I think that's starting to get a little more advanced than I want to get into on this video, how you actually program it to give you the mode out of this. Yeah, it's a little bit more advanced than I think you guys need to jump into yet. Okay, so that's how we do that. Okay, so this problem is one involving obtaining a trimmed mean, which I went over in class how to do that, but I'm going to show you how to do it in Excel now. So let me go over here and get this data. So we have, let's just read through it. So it's talking about sometimes you get outliers, and we want to talk about how to compute a trimmed mean, where you delete high and low observations and we trim them off. So let's go ahead and this one, we're going to do a 10% trimmed mean. This displays a set of scores for a 40 question algebra final exam. Now that doesn't mean we're going to have 40 data values. This is like a bunch of students took this test and everybody had a 40 question exam. So let's go in and see what they want us to do. Do any of these scores look like outliers? Okay, well, the first one, there's no math really involved. So let's just see what when we look through this, we're like, okay, 2, 4, 15, 15, you know, we kind of look at this and we're like, okay, looks like most of the scores are somewhere in the low 20s, maybe there's some down as low as 15, but this 2 and 4, boy, they're really low, right? So I would say, yeah, the 2 smallest scores appear to be outliers. All right, so that's true. Okay, now compute the usual mean of the data. All right, so this is where probably the easiest thing to do at this point is just to copy this to the clipboard. So again, we're going to do Control-C on my laptop, or right-click and do copy. And I'm going to come back over here to Excel. So now I need another blank space to work in. I'm just going to go back over here to A1, and I'm going to copy it here. So I have this data here. And these are all the scores already ordered for me. Thank you. And I want to find the mean. So I go over here to the mean. I already had the mean typed in. It's the average function in Excel. And I'm like, okay, well, that's only getting part of the data. So let me adjust the size of this box. I'm going to slide this box up to the 2 and pull the bottom of the box out down to the value of 29. And I'm going to hit enter. So I see that the mean is 19.55. And also because I went from A1, I can see that I have 20 values in my data, by the way. So let's go back over to the problem and say, okay, well, we know that the mean is 19.55. All All right, let's check that answer. Okay, next, compute the 5% trim mean of the data. Okay, so let's do that next. Let's go over to Excel and figure out how to do that. Okay, so I'm going to just write down here 5% trimmed mean. And I'm overflowing, so I'm going to make this just a little wider. So you can either make your columns wider or you can wrap your text. Okay, so now I'm going to come over to this cell, go up here to the formula bar. And I'm not sure exactly, because I don't use this a lot, how to do this in Excel. So I'm going to hit this function and I'm going to say trimmed mean and hit go. Please rephrase your question. So let's try that. How to find trimmed mean. Didn't like that. Why is this not working so well? Trim. Okay. All right. So stop. All right. Let's try this again. Okay. Start. We're going to come over here and we're going to click on the formula bar and click this little function so we can get some help on finding this. So in here, I'm going to say trim mean and see what we can find. Oh, so here we see there's a trim mean function. We're going to say, yep, that sounds, let's read it. It returns the mean of the interior portion of a set of data values. Perfect. Let's try it. So it's going to pop up this little window. It's going to allow us to decide how to, it's going to guide us through setting it up. So the array. So the word array is a mathematical word, which means a set of values that are arranged in rows and columns, just like you see in Excel. So we can put values that are across rows and columns. Now, our data is all in a column, so we're just going to select it, and that's fine. Then now I can hit tab to get to the next window and the percent. So it wants the percent, returns the mean. So it tells you is the fractional number of data points to exclude from the top and bottom of a data set. So I believe what we want to put is 0.05 here, not a 5%. So I think if I hit 5, let's see what happens. I believe that's going to give me the wrong thing. So you can get help on this function. And it's going to open up an Excel file. And sorry, let me share that. Let me share that with you guys. So it opens up this function, this website, right? And it tells me you can't provide a number that's less than 0 or greater than 1. So that kind of guides you that you need to provide this as a decimal. Okay, so let's get rid of that. We're done with that. So we definitely want a decimal here. So we want the 0.05. Right, we're good. I'm going to put that in. We say OK, and we get that the 5% trim mean is 19.55. Let's go back over to our problem. Oops. And we say, OK, the trim mean, the 5% trim mean is 19.55. OK, check answer. That's incorrect. Huh. What happened? Try again. Trim mean. So let's try to figure out what's going on here. Let's go back in here to this function button and hit on, let's click on the percent. So it's the fractional number of data points to exclude from the top and bottom of the data set. Okay, so I think what it's doing, and I think I mentioned this in class when I went over the trim mean, that there is a little bit of inconsistency in what the trim mean is defined to be. when you give a percent. So you have to be really clear when you use it. And this is one of the reasons I don't like using it very much, is that you have to say 5% off all the data or 5% off the top and 5% off the bottom. Like, what do you mean? So the way the textbook and the way I usually use it is I take, when I say the word trim mean, and I think the E text is the same as me, we intend that to be the same amount off the top and bottom. So if it's a 5%, you take 5% off the top and bottom. Excel is doing a total from your data. So if you want to do a 5% trim mean in Excel, if you want Excel to give you a 5% trim mean, it's going to be doing 2.5% from the bottom and 2.5% of your data from the top. So let's cancel this. Let's get in here and say, okay, for a 5% trimmed mean, so total from the data is 10%, right? According to Excel. So Excel, so let me actually write this out. So Excel, so the trim mean function, Excel's trim mean function takes percent off and splits it between the top and bottom of your data. Okay. eText and my lecture takes the percent off from both top and bottom. Therefore, we use the trim mean function. We need to double the percent desired. So for a 5% from both top and bottom, we need to tell Excel to remove 10% of the data, because Excel is going to take whatever percent we give divided by 2 and take that amount off top and bottom. So let's see that. So a 5% trim mean, so this was wrong. So this was the wrong answer. Sorry, I got a single quote. Wrong answer for the MyLab. Okay, so let's come back here and let's try again. So so a 5% trimmed mean. And what we're going to do is we're going to tell Excel 10%. All right, because again, Excel's doing it different. So Excel is taking what percent we give it, dividing it in half, and taking it off each end. And so we're going to say this is going to equal the trim mean. We're going to pick that same data, but we're going to tell it 10%. So the percent is 0.1 for 10%. And now we get 20. So let's try putting that answer in MyLab and see what we get. So it didn't like this. So let's try putting in 20. Okay, so that's worked. Okay, now the 10% trim mean. So we want to get the 10% trim mean. So let's come back here and we're going to say 10% trimmed mean. We're going to tell Excel to double it, because we want it off both ends. Tell Excel 20%, right? So what we get is equal. Oh, by the way, I'm going to show you another Excel trick. So let's say I want to come in here and I want to copy this formula down. I can just select that cell. I hit Control C. And if I come down here and paste it, I can right click and hit paste. Notice that if I now select this formula up here, the blue bar is all off. So one way I can fix it is I can just wait. I can hover over the top of the box until I get the 4-pointed arrow and I can drag it to where it needs to be. Okay, another way that I could do this, if I know I'm going to be copying formulas, and is I can come up here and this formula that I want to copy, I'm going to say, okay, well, I'm going to move it down 1, 2, 3 rows. I don't want this blue box to get shifted down 3 rows, which is what a relative reference will do. So I'm going to highlight that and I can hit function F4 and it's going to put dollar signs. It's going to freeze that. The formula doesn't change, the result doesn't change here, but when I copy it, I now have frozen the reference. So when I copy it, it's not shifting it for me. So now it's still pointing to the right spot. But the only problem now is the formula still says 10%. So I still, if I want a 10% trimmed mean, I need to tell Excel to take 10% off top and bottom together or 20%. And so we get a 20.56. So let me go over here to MyLab and put in the 10% trim mean. Oops, is going to be 20.56. What does it say? Round to 3 decimal places as needed. Okay, 20.563. Okay, check answer. Excellent. All right, so there we go. That's how we did that trimmed mean in Excel. Now that we've done the trimmed mean, let's go in and see what we're actually doing. So let's turn our brains on now. Okay, now we kind of turn off the calculator part of our brain and turn on the business, like why would this matter and why are we learning it part. Okay, so now we're going to compare. It says compare the means you obtain in B through D. Which of the 3 means provides the best measure of center of the data? So first, the overall mean was 19.55. Again, those lower values were pulling the mean lower. A 5% trim mean took us to 20, and a 10% trim mean took us to 20. I'm just going to round 20.6 or 21. So which do you think provides the best measure of center? Well, the 10% trim mean is the best measure of center for the data since there are no outliers affecting its computation. So maybe they want to know how many values we're removing, right? Okay, the 5% trim mean is the best because there are no outlier affecting its computation. And since all the 3 means are approximately the same, any of the 3 would provide approximate center. And the usual mean is the best answer because the data does not appear to contain any outliers. Okay, so we actually need to go back and let Excel tell us how much data was actually removed. So let's go ahead and calculate what 5% of the data is. So that's going to be equal to 0.05 times the number of data values. So to get that, we're going to use the count function. Count, and we're going to count up this data here. So with count, it's 1. So we took 1 data point off the bottom and 1 off the top. So since we thought that 4 looked like an outlier, 5% of the data does not look like it's sufficient enough of a trim to remove what look like outliers. So let's try for 10%. Let's see how much of the data is removed there. Again, I'm going to use that same formula. I can copy it, but I'd have to make those absolute references, or I can just retype it as probably the fastest. Changing that to 10%, 0.10 times the count. So let's count this up. Okay, there we go. We're going to hit enter and we get 2. Okay, so now we're going to take 2 values off the bottom and 2 values off the top. So it looks like the 10% trim mean will eliminate these 2 values that appear to be outliers. It is going to also trim 27 and 29 off the top, and that's what happens. We're looking for a measure of center, so we want to do this symmetrically. But it does look like that probably is our best choice. So going back over to MyLab, we're going to say we're going to do the 10% trim mean is the best one because it's removing what appear to be outliers and is doing a calculation excluding outlier values. Okay, so we're done there. Okay, so this problem I also want to show you how to do in Excel. This one is where we're going to use the mean versus the median applet to answer the questions. I don't really want you to use that. I'd rather you do it in Excel. Let's see what that does though. All right, I'm going to show you how to do this problem doing Excel. So let's go ahead and I'm going to put this here and I'm going to click on Excel. Notice it covers that, so that's not so helpful. So I'm going to shrink Excel so I can see this table. And what I'm going to do is I'm going to create a data set. So this I'm going to call this question 12. And notice I'm just kind of using this Excel like a scratch piece of paper in a sense, but it's doing a lot of calculations for me. Okay, so here's the data. I want to have the observation value of 10, and I want that 4 times. So notice that I have 10, and I'm just going to drag it down to have 4 values of 10. Now I need 20 to have a frequency of 10. So I'm going to copy 20. Oops, sorry. I'm going to type in 20. And notice that 20 here is, I can look up here in this gives me my address. So 20 is at 18, row 18. So I'm going to drag this down till I hit row 28. And I've highlighted, notice that it gave me a count of 11. And that's because it started, I needed to add, I've added the first row 28 and I added 10 to that. So I'm going to delete the last one. Okay, then I'm going to add 25. And I'm going to add 5 of those. So I'm going to drag that down. If I want to again add, remember we're going to add, we're at 28 and we went, and that counts as the first one. So then we need to add 4 more. So 28 plus 4 is 32. So we're going to go down to where we're at row 32. And so again, we're going to count the count down here on the highlighted, gives me a count of 5. All right, so now we got 40 and we're going to have 3 of those. So I'm going to just drag this down. There's a little green box in the lower right corner, and that's what I'm dragging to copy whatever I just typed in. So now I'm going to put 60, and that one I'm just going to type in twice. Okay, so here's some data, and it has this frequency. And then it says, calculate the mean and the median. Which of the two statistics is larger and why? All right, so let's try that. Let's do the mean. We can come up here. Let's just say mean. And so we're going to equal the average from this data set. And that's 25.2. And the median is going to be this column of data. And we get 20. So we're going to look at this data, and we have 10, we have a bunch of 20s and 20, and then we have these 2 60s out here. So part of the reason the mean is bigger than the median, right, is because it is sensitive to the influence of a few extreme observations. And so that looks like that's the correct answer. So we're done with that question now. This is going to be a question where I'm going to take the data. This is question 27 from the homework, and I'm going to determine the quartiles. So again, I'm going to copy it to the clipboard, and I'm going to copy that over to Excel. And just come down here. I'll just call this question 27. And I'm going to put the data here. So I'm going to either right click and hit paste, or I could also have done Control V. Okay, so we want to obtain the quartiles. So one way to do this question is asking about quartiles, and I want to show you how to do that in Excel. So I'm going to grab, this is question 28. I'm going to grab the data out of here, copy it to the clipboard. Again, right click and hit copy or Control C. I'm going to come over here. Let's go ahead and set this up in here. Let's call this question 28. And I'm going to put that data in here. Right. So we have all this data and it's not in order, which is what you would do if you would do by hand, right? You would have to get this data in order. So let's see if we can get Excel to give this to us automatically. Excuse me. So let's start out by using something in Excel that if you don't already have it, you might want to download it, and that's this data analysis add-in. You can get it by going to File, come down here to Options at the very bottom, and then go to Add-ins. And at the very bottom where it says Manage Excel Add-ins, hit the Go button. And then here, make sure you have the Analysis Tool Pack checked. And once you do that, you'll have this Data Analysis button show up. In here, you can click on this, and you can check on Descriptive Statistics. And that's what we're going to get for our data. I'm just going to double check that there isn't just a quartiles. There is not. I didn't think so. Okay, so I'm going to hit Descriptive Statistics. It's going to say okay, and it's going to want to know the input range. So I'm going to come down here and select this data, and it is grouped by columns, and there is no label in the first row, so I'm not checking that box. And it wants to know where the output's going to go. So I'm going to say the output is going to go right here. And then down here, it's going to ask me, and I'm going to check which of these things I want. Now, this is the percentiles, largest or smallest. We're just going to click Summary Statistics, and we'll click OK. Now that we got this, it doesn't help us. All right. So let's get rid of that. Actually, let's clear everything here. Editing, is it? I make this bigger. It's gonna clear all. Okay. All right, stop and start again. All right, so we're going to see if we can get Excel to give us the quartiles. So let's go ahead and in here, let's go ahead and type Q1 and Q3, because we know the median is Q2. So really what we know how to get Q2, actually we can just do that. We can say Q2, which is equal to the median. And then down here, I'll do Q3. So let's put these functions in here to get us this. So we're going to hit quartile. Now, if you notice, we have quartile exclude or quartile include. So if we go to quartile exclude, it returns the quartile of the data based on a percentile value from 0 to 1 exclusive, which means it's going to exclude 100 when you have 100% of your data. So the one that I recommend is the quartile INC for inclusive. So we'll use this data. We're going to select this data set here. And then we're going to see that we obtain these options. And basically Excel is kind of stepping us through what we want to put. So if we want Q1 or the first quartile, we'll put a 1 here. And you can see that by, I can hit the down arrow key, or I can just have typed 1. But let's say I pick that, and then I close the parentheses here, and I get that the first quartile is 7. I can either type median or Q2 here. So either way, so let's just make sure we're clear on that. So median, I could select this entire, column of data. Whoops, I didn't get it all. Let me try that again. There we go. Did something get messed up? Sorry, I think something messed up. Escape. Okay, so if you accidentally do something like that, you can go back to this on the home key. You can go to this undo button. So let's go in here and see what we got. Okay, we didn't get all our values. So let me extend the size of this box down. There we go. All right, so that's if I type median, and if I type quartile inclusive, and I include this data set again, comma 2, the median value, I should get the same thing. And I did. And then I can go to Q3 and just do the exact same thing again. Another way to do this, right, is to go up here to Q1 and highlight these cells, hit function F4, make them absolute references, and then copy this down to Q3, come down here and change this 1 to a 3. And so now we get that it's 21. So let's go ahead and put these values in here. So we have 7, 13, and 21. Okay. The next thing is we want to interpret the quartiles. So the quartiles suggest that 25% of the patients stayed less than 7 days, 25% stayed between 7 and 13 days, and 25 stayed between 13 and 21 days. And then 25% stayed more than 21 days. So that, to me, just thankfully, the first one we read is the first one that I think is accurate. It interprets the quartiles accurately. Determine and interpret their interquartile range. All right, so this is where, you can set this up. Oops. And this is just simply the third quartile minus the first quartile. And so we get that it's up here, you can see it. It's 21 minus the 7, and that gives us the 14. Let's put that in here. Let's check this answer. All right. Next thing we're asked to do is interpret it. The approximate difference between each quartile is 14. Nope. The length of stay in the middle 50% of patients spans roughly 14 days. That's true. The data spans roughly 14 days. No, the data spans a lot more than that. The average of the first quartile and the third quartile is 14. Nope, that's not true either. So the one that is accurate is the one that's talking about the middle 50% of patients. And the span of days is roughly 14 days. Okay, next up, we want to find and interpret the 5-number summary. So over here in the data, you can very quickly span it maybe and see it, but you could also just have Excel find it for you. So we have 3 of the 5 numbers for the 5-number summary. We need the minimum, and we can get that by getting the minimum of the range of data, which is 1, and max of the range of data. So it's just max of this range of data. And we get 55. All right, so our 5-number summary is going to be starting with the minimum. So we have a 1, and then we have quartile 1, which is 7. We have the median or quartile 2, which is 13. Again, we're typing these all over again, and 21. And now we're going to add the 55. So check that. Yep, that worked. All right, next. We want to interpret these. There aren't as many patients in the 4th quarter as there are in the 1st quarter. The 1st quarter has the most patients recorded. No, okay, all of these have the same number of patients. The middle 50% has the greatest variation in the data set. The 1st and 4th have the same variation. I don't think so, because from 1 to 7, that's like 6, and then from 21 to 55 is a lot more. The 4th quarter has the greatest variation. I think so. The middle 50% has the next largest variation, and the first quarter has the least variation. So I would say that appears to be the case, right? From 21 to 55, we're talking 24. No, sorry, 34. And a range of 34, and between the first quartile and between the minimum and the first quartile, there's only about a range of 6 values. 6. So this appears to be the right answer. Okay. Then this question asks us to identify if there's any potential outliers. So we can do this by simply using 1.5 times the interquartile range and determining if any numbers are above or below the first quartile minus 1.5 times that, or third quartile plus that. So let's go ahead and get 1.5 times the interquartile range. So that's just going to equal 1.5 times, and let's go up to this interquartile range. So we have the lower fence, and this is going to equal the first quartile minus 1.5 times the interquartile range. And then we have the upper fence, and that's going to equal the third quartile plus the 1.5 times the interquartile range. All right, so this is -14 and our minimum was 1. So our minimum is bigger than the lower fence, so that would imply no low valued outliers. And now we look at the 42 and we see our max was 55. So it appears that we at least have one outlier. And what we can do is we can reorder this data. So I can select this data. I can go up here to the data tab and go to sort. And I'm going to sort this data from smallest to largest. And I see that the upper fence was 42 and 55 is one outlier. So it appears one outlier over the upper fence. Right? So it would appear that this is an outlier. So let's go back and see how we're going to answer this. Potential outlier is R, 55. Okay, let's check this answer. Okay. All right, so now we're on to construct and interpret a box plot. All right, so it wants us to determine which of these box plots is an accurate box plot. So let's look at this first one. It looks like it's got an outlier out here at the 55. It's got the upper fence. Is that at 42? No, that's far from 42, so that can't possibly be right. Let's look at B. This one looks like it has a, sorry, actually, I take it back. I think this was right. I think I just too quickly was looking at the upper fence when actually what I want to look at is the highest value in the data. That's, let me shrink this up so make sure we can see. We want the highest value in the data. The whisker, the right whisker is going to go to the highest value in the data that's within the upper fence, and that would be 25. So again, let's see if we can make this bigger somehow. What happened to that? There we go. Can we pop this out? You guys figure that out? Yeah, there we go. Right. So here we're going from 25. The lower fence, the lowest value that's within the fence is a 1. So that looks accurate. The Q1 at 7 looks right. The Q2 at 13 looks right. And the third quartile at 21 looks right. And then we have this outlier of 55. So that one looks spot on. So let's pick that. So we completed that question. Okay, and now the next part is to interpret the box plot. So the potential outlier observation falls far from the rest of the data. The other stays vary from 1 to 25 days. The majority of the stays were between 7 and 21 days. That's exactly what that box plot's saying. This one's saying the potential outlier is relatively close to the other data points. Nah. Most days were approximately 19 and a half days. And the longest day, no, this doesn't seem to have anything to do with our data. The two potential outlying observations fall far from the rest of the data. Well, according to our analysis, we only had one outlier, so I can just stop reading right there. So this appears to be the right answer. So let's check that. Okay, so we are now done with this question.